Hello everyone, welcome to the official YouTube channel of Lightway Research and Technology Center. I hope you are doing well. In this video, I will show you how to perform and interpret descriptive statistics in Eviews. Before I proceed, please, if you are just watching our video for the first time, or if you are just coming across our channel for the first time, please click the subscription button below to be part of us. Also, hit the bell icon button so that you can receive notifications when we post or release new videos on research and data analysis. Let's get back to work. Descriptive statistics are sets of tools used to summarize and describe the main feature of a data set. You see, as an analyst, you must understand the nature of your data before you proceed with your statistical analysis. So, descriptive statistics provide a way to present your data in a concise and understandable manner. So these particular statistics are essential for analysts to gain an initial understanding of the data set, the characteristics of the data set, such as the central tendency, the distribution, as well as the variability or dispersion. So descriptive statistics provide a foundation for further statistical analysis, and it helps data analysts to identify the pattern, also to detect outliers and make comparison between different data sets. We have categories of descriptive statistics. So the first one is measure of central tendency, and that is the mean and the median. Of course, we have the mode, but Eviews doesn't provide the mode except you want to generate it yourself. But the statistical results that you will get when you perform descriptive analysis in Eviews will give you the measure of central tendency, which will comprise the mean and the median. Next to that is the measure of dispersion or variability, and that gives you the maximum, the minimum, as well as the standard deviation. And another one is the measure of shape or distribution. That's the skewness, the kurtosis, and the jagubera. So below all these results or statistics, you have your observations. You get it? So now, when you have all these results, you will have a clear idea of how your data or your results will look like. Now let's go to Eviews so that I can show you how to perform these results and also explain how to interpret or even interpret the statistics for you. Now, for you to perform descriptive statistics in Eviews, you must first be able to identify whether your data is complete or not. For instance, if you have your data sets, let's say from 1970 to 2024, and for a variable you have mixing data, or 2 or 3 variables you have mixing data, in that case your data is not complete. Of course, you can perform statistical analysis, but your data is not complete. But in a situation whereby you have all the observation for the variables, then you have a complete data. So when you have a complete data, once you click on this MVA, that's manufacturing value added, then you press down your control, you click on employment, capital, and exchange rates. You understand? So once you click on this, you can go to quick, then you go to group, you go to descriptive statistics. Here you have common samples. In a situation whereby you have complete data, no mixing data, that's you pick common sample. But in a situation whereby you have one or two mixing data, then you go for the individual sample. But in this case, we have all the data complete, so we are going to make use of the common sample. So once you click on common sample, since these variables have been highlighted here, you will automatically have them in this window. But if you did not highlight the variables here, then you have to enter the name one after the other in this box. But I always prefer to highlight the variable, then proceed with the analysis. So here, because when you are entering the name here, you may mistakenly type another variable, or even miss the label or miss the variable. But once you highlight the data or the variables, you want to check their descriptive, you want to check the descriptive here, then you will have all the variables here automatically. So you click on OK, then you have your statistics. Here we have value, manufacturing value added, employment, capital, and exchange rates. Now if you look at the first one here, statistics, that's mean and median. That's what? The measure of central tendency. Next to that is the maximum, the minimum, the standard, deviation, the skewness, the kurtosis. Now, your maximum and your minimum, let me go back to this so that you can get it. You can see now your maximum, your minimum, your standard deviation, that is what? Dispersion. While skewness, kurtosis, and Jagubera is what? Distribution. So let's go back to Eviews. You can see now, so now your maximum, your minimum, and standard deviation is what? Measure of dispersion. The first two is measure of what? Central tendency. That's the mean and the median. The maximum, the minimum, and standard deviation is those ones measure what? The dispersion. Now for the measure of shape or distribution, that's where we have skewness, kurtosis, Jagubera, and the probability of Jagubera. The skewness here measure the asymmetric or lack of asymmetry in this particular data set. So it's in this skewness indicates whether this particular data set, that is for manufacturing value added, for instance, it indicates whether manufacturing added skewed toward one side, or the distribution is evenly, or it is evenly distributed around the mean. You know, we have the mean now. So this skewness tells us whether manufacturing value added skewed positively or negatively, that is to the right, that is positive, to the left, that is negative, or whether it's evenly distributed around this mean value. While kurtosis, on the other hand, measure the thickness or the flatness of this particular variable, and in this case it shows whether it is what? Leptokurtic or platykurtic. Most times we don't interpret this. We don't interpret this in our analysis, except you are working on a project, maybe undergraduate or your thesis or your doctoral thesis. You may explain those two statistics. But when you are writing a paper, an article, you don't really need to present the kurtosis and skewness. And yes, once you present your Jagubera, which measures your distribution, Jagubera, for this Jagubera has skewness and kurtosis in it. In other words, skewness and kurtosis are used to compute Jagubera. So instead of discussing skewness, kurtosis, you can just focus on what? On your Jagubera, which is a measure of normality. So when you want to know whether this particular variable is normally distributed or not, what you just need to focus is your probability. If the probability value is greater than 5%, then you can conclude that what the variable is normally distributed. In this case, all these variables, manufacturing value added, employment, capital, and exchange rates, they are all what? They are all normally distributed. Why? Because the probability value is more than what? 5%, which is the conventional level. So we can conclude based on the value of the probability value that what? Manufacturing value added, employment, capital, and exchange rates are what? Are normally distributed. Next, that is very important, is observation. Let me go back to here. You can see from here that my observation starts from what? 1990 and it ends in 2021. So I have 32 observations. So that's what it's saying here. 32 observations. In a situation whereby you have missing data, let's assume you have 2 or 3 missing data for employment, it won't be 32. If it is 2 missing data, it will be 30. So that's why I explained earlier that when you have mixing data, you need to pick individual. But in a situation whereby you have complete data for all the variables, you just pick the common sample, and you can see from here that I have 32 all true. Now let me show you how to interpret these results. The mean here tells you the average. So now the average value of manufacturing value added between 1990 and 2001. I want to check the stats and yes, 1990 and 2001 is this 4.29. That is the average value. And also I want you to note that when you are computing descriptive statistics, you need to use the raw data. Don't use logged data. Don't use a transformed data. Yes. Don't use a transformed data. Use the raw data. Do you know why? The reason is just that we want to know the nature of our data. How does it look like? Is there any problem of outliers? Is there a problem of non-normality? Yes. Is there any problem of non-normality? And so on and so forth. So those are the things we want to know. So when you are running descriptive statistics, make sure you use raw data. So now this mean tells us that the average value of manufacturing value added is what? Is 4.29. In case if you are doing comparative analysis, for instance, if you are comparing the manufacturing value added of Nigeria with that of Canada, for instance, what you just need to look at is what is the mean of the manufacturing value added for Nigeria and what is the mean for Canada. So now when you notice that the mean of the manufacturing value added of Canada is greater than the mean of the manufacturing value added for Nigeria, you can then interpret the results as, okay, the average value of manufacturing value added for Nigeria is low compared to that of Canada. In other words, the value added to manufacturing products in Canada is higher than that of Nigeria. When you read articles, you will notice that authors or researchers they interpret all these things, all these statistics in a different way. Yes, they interpret it in a different way. What you just need to look at is, what am I working on? What is best for my interpretation? There are in another situation, when you are working on a single country, you can just say, okay, manufacturing sector contributes this amount to the total what? You know the total value added for all the sectors. So manufacturing sector contribute this particular to the total value added in the country. Now for media, it simply tells us the middle what? The middle value. You see, this is very important, particularly when you are dealing with quantile regression, this particular median and Jagubera. If you notice that your, ordinary least square regression estimates the mean, the conditional mean. So when you notice that the Jagubera is not normally distributed, that is, the probability of Jagubera here is less than 5% for any of these variables, then least square regression is not the best. You have to switch or to make use of constant regression. Why? Because constant regression focuses on the conditional the median. It focuses on the median or the distribution. You can estimate, you can get results as different quantile or percentile. So now when you notice that any of these variable is not normally distributed, then you can make use of quantile regression. Now the maximum here tells you the highest value. The highest value here for manufacturing value added is this. This is the highest value. Why this minimum tells us what? The lowest value. If you combine these two together, you will have what? You will have the range. These two gives us the range, maximum minus minimum. But you may not really need to interpret that when you are writing or when you are working on a research paper, particularly article. But if you are as an undergraduate student, you may need to provide more explanation. But if you are working on, if you are writing a paper, article paper, you don't really need to focus on the maximums, the minimum. The next thing is the standard deviation, particularly if you are working on a finance issue. If you are in a maybe financial economics field, this is this standard deviation. It tells us the variability, the volatility in the stock exchange market. So when you are writing your paper, you need to provide more explanation of standard deviation, particularly if you are working on finance issues, like if you want to know the nature of stock markets, the All-Share Index, and so on and so forth. Now I have explained this observation. It tells us the numbers of observations in our data set. Okay, now I want to take a look at 3 different papers so that you will see how they present descriptive statistics and possibly how they explain, the authors explain descriptive statistics in their paper. The first paper I will take a look here is this paper, VOSI energy consumption, carbon dioxide emission, and adult mortality rates in Nigeria. Now let us look at what the statistics the authors presented and how they interpreted the statistics. Okay. Yes, we have the descriptive statistics here. You can see the author presented 5 statistics: mean, maximum, minimum, standard deviation, and observation. Let's look at another paper. This particular paper, energy crisis, firm profitability and productivity, and emerging economic perspective. Let us look at how many statistics they presented in their paper too. Okay, we have it here, table 5. These authors too, they presented 5 statistics: observation, mean, standard deviation, minimum, and maximum. Very similar to this one. Now the third paper I will take a look is this: inflation, oil prices, and economic activities in recent crisis. Evidence from the UK. You can get this 2 paper on Science Direct, this particular one, energy economics, and this one, energy strategy review. Now look at the third paper. Let us see how many statistics they presented. Okay, we have it here. Descriptive statistics: mean, standard deviation 2, median 3. I believe they computed all these ones, but these ones are from the Eviews results: mean, minimum, maximum, Range, that's the difference between maximum and minimum. Skewed, that's skewness, kurtosis, and standard deviation. So basically they presented 5. So when you are writing your paper, those are the key statistics you need to report. Now let us take a look at how these ones interpreted the results. Okay, table 2, look at it. Table 2 summarize the statistics of the adult mortality rate. Now, the average adult mortality rate is this. So, this is bigger than the mean value of this for sub-Saharan Africa. So, what these authors did is that they compare the average of each of the variables with that of sub-Saharan Africa as a whole. You know, Nigeria is part of sub-Saharan Africa. So what they did is just to compare what is the average in Nigeria, what's the average in sub-Saharan Africa, so that audience or readers will see what Nigeria as a country is consuming, or what the performance of Nigeria as a country compared to what the performance of sub-Saharan Africa as a whole. Now let's look the next statistics. The next one, yes, okay. I believe these authors they focus more on the mean, which is very, very important. You know, they are not working on stock exchange market, so they lay more emphasis on standard deviation and so on and so forth. Now let's move to the second paper. This one, let us look at how they interpreted their results. We have already confirmed that they presented just 5 statistics. Now look at it. Table 5 presents a summary of the descriptive statistics of all dependent and independent variables for the period 2001 and 2017. Now they are telling us what is the mean value of return on assets is this, and the mean value of return on equity is what is this. The author now made it clear that what one is higher than the other. Take note, both return on assets and return on equity are measures of what profitability. So this shows that these companies are less efficient in generating earning from assets than what their equity. Why? Because the return on equity is higher than the return on assets, which is 2.9. You can see now that, but if someone in energy economics will interpret the average, their presentation will be different. You know, as I made it clear the other time, that when you are working on finance issues, your interpretation must be positioned within financial economics. So for the researchers or the authors in energy economics, the way they will interpret their results will be different from the way someone that is in financial economics interprets the average. So you should take note of that. What you are working on will dictate the tone of your interpretation. Yes, what you are working on will dictate the tone of your interpretation. Now let me look at other statistics. But majorly, I believe the authors too will emphasize on the average and lay more emphasis on other values. If you go through it, you will see that's just the key interpretation from their results. The average, the average, the average. Others are just supportive to the average. Now let us look at the third. We have also confirmed that these authors presented 5 statistics. Majorly 5 statistics: the mean, the maximum, the minimum, standard deviation, observation. So we have this is what? This is their, yes, descriptive table, table 1. Now let us look at, you can see, table 1 shows the descriptive statistics of the variable in this study. The average recorded, you can see the average, that's the mean. Change in GDP within the UK was 2.99, why the average change in inflation was this over the period of this. This indicates that inflation was on average in terms of percentage change than GDP in the UK in more than 2 decades. What these authors did was just to compare the average of inflation to the average of GDP. You can see now that they also position their the feed also dictates the tone of what of their interpretation. You can also see that the table also shown that the average of percentage change in trade balance, unemployment, and crude oil were this. So by comparing all variable, we can see that the standard deviation of this in UK was more larger than the other. So now that is, I mentioned is that standard deviation is either variability or dispersion or instability. No, so this highlights the instability of unemployment, or volatility. If it is in finance, they will use volatility. You can get my point. So the feed, your feed will dictate the tone of your interpretation. So now it is because this is macroeconomics, that's why they use instability. If it is finance, stock markets is volatile, is not volatile, those are the arguments there. So they will use volatility. So standard deviation indicates volatility, instability, variability, the changes or dispersion. So that is that about descriptive statistics. So with that, we have come to the end of this particular video on how to perform, interpret, and present descriptive statistics obtained in Eviews. Again, please, if you are watching us for the first time, kindly click on the subscribe button below to be part of this channel. Also, make sure you click on the bell icon so that you can receive notifications whenever we release new videos on research and data analysis. And to our existing subscribers, I say thank you for your comments, thank you for your feedback. Please do share this video, like, and comment. Thank you.